Hi, welcome. My name is Krishna Mohan Raju, Yenugudati. Today, we are discussing how the government agencies build a secure access service edge. We're calling it a SASE as well. We will cover the why, the, the core technical parts, how IRAP and FedRAMP complaints shape the design, and real world lessons. By the end, you will know exactly what a government grade SASE platform look like. Let's talk about the catalyst for change. Why SASE? All networks can't handle advanced state-sponsored attacks. Also, hybrid work made sending all traffic through a central data center too slow. Agencies needed security tied to the user and device, not a physical building. Compliance frameworks like Australia's ISM and NIST SP now demand policies enforced anywhere without a fixed perimeter. Let's talk about the core competencies of SASE. SASE combined 5 cloud-delivered tools. SD-WAN routes traffic smartly. And then Zero Trust Network Access, ZTNA, replaces VPNs with the identity-based access. And then secure web gateway filters outbound traffic. And next is Cloud Access Security Broker, CASB, protect data in app like AWS and SaaS applications. And now let's talk about the firewall as a service, protect the edge without hardware. The big win is a single pass inspection. Data is processed once by all engines at the same time, making much faster. That is the biggest advantage of these 5 core competencies of SASE. Now let's talk about the complaints foundation from both Australia and United States point of view. All right. Let's look at complaints in Australia. IRA protected the requires data in stay in country, managed by cleared staff. In the US, FedRAMP High uses NIST with a US data residency and a third-party audit. Both share a rule, if you observe. Trust must be proven and verified continuously. Vendors must build this in from day one. You can't just add a complaints later. That's the biggest thing why the complaints is engrossed into the process and policies and audits. All right. Let's look the Zero Trust multi-contextual evolution. Zero Trust checks the 4 things for every access request. Identity, who is the user? Task, does the action make sense for their job? Environment, is the device secure and patched? Data, how sensitive is the data? Following NIST, the policy engine, which makes decisions, must be separated from the policy enforcement point, which carries them out to avoid single point of failure. Now, let's talk about the most important topic, the sovereign SASE and 3-layer separation. Government needs sovereign SASE to keep data within the national borders. It has 3 layers. The control plane manages policies but doesn't touch user traffic. The data plane inspects the traffic locally so data never crosses the border. The user plane uses agents to create encrypted tunnels to local point of presence. This setup proves IRAP and FedRAMP data residency compliance. All right, let's talk about the independent topic, which is going to helpful for our future slides and paper. Technical controls and encryption standards. Government's setups require strict cryptography, AES for encryption, SHA-2 for data integrity, and strict TLS 1.3. Or HSTS is mandatory to stop downgrade attacks. For key exchange, there's various government standards are there. For key exchange, ECDH keeps past traffic secure if key is stolen. These maps FIPS, NSCS, a new NIST post-quantum standard. These are the strict rules, not options. So these cryptographic requirements and government standards are something that we need to be understand these requirements and standards for our future discussion purposes. All right, let's understand how we can automating authorization complaints as a code. The old audit model is too slow, as you know that, right? Now we use compliance as a code. Agencies use NIST ASCOL, a machine readable format linking ASM and NIST rules. SASE feeds data here for continuous authority to operate. That's the biggest differentiation, right? It's a SASE feeds data for the continuous authority to operate. Compliance is checked in real time. That's the biggest differentiation in the SASE, right? Compliance is checked in real time, blocking bad setup before to go live. This cuts audit prep time to be 70% while improving security. All right. While we implement, let's talk about the real lessons from a real world deployments. In the real world, lessons show technology isn't enough. In Australia, cleared local staff running 24/7 operations were key. Apart from the processes and technology, the cleared staff running the 24/7 operations is a key. That's what the main purpose of the cleared staff, right? Who has been having NV1 clearance in Australia. In the US, a Versa network showed a value being FedRAMP high ready for critical edge and cloud access. Is one of the SASE third-party cloud provider. The main lesson is plan your vendor strategy early based on the local government policies and processes, what the vendor supports. Have this planning early in the stage. Delaying leads to the delaying of this audit leads to policy drift. Where is a mixed setups create expensive compliance gaps. Decide your vendor strategy before you deploy, not after that. Okay, that's the biggest differentiation. Now let's talk about how the future outlook look like. AI and post-quantum cryptography as an example here, right? The future of government SASE relies on two things. First, AI. It learns what normal user behavior looks like to lock out normal activity instantly. Second, post-quantum cryptography. Hackers are stealing encrypted data now to decrypt it later when quantum computer arrives. New NIST standards like Crystal Kyber are being used right now to stop this. Crypto agility is a must-have today. Thank you very much for giving me this opportunity to went through this paper. Hope you got a complete understanding. If you have any more further questions, feel free to send an email to me or give me a comment. I will definitely respond to that. Thank you very much.